Thank you. Thank you. And welcome back to everyone's favorite game show. Which AWS storage service do I use for my use case? Today we have one contestant during the final round of our show, and that's you.
In order to win the grand prize, you must answer the next 3 questions correctly. There will also be a bonus question, so there's an opportunity to get extra points. All right, once we read the question, you have 5 seconds to answer to get points. Let's get started.
All right, this is the first question. Let's say you're a developer and you plan to build out an application to transcode large media files like videos. You'll be using an AWS Lambda function to perform the transcoding, but you need a place to store both the original media files and the transcoded media files. Due to regulations, you need to store these files for at least a year. Which of the storage services that we've talked about in this course should you use? You have 5 seconds to answer. And the answer is Amazon S3. Why is S3 the best solution here, Morgan?
Well, first of all, the question says that they're using a Lambda function. Because of that, I'm already ruling EBS out, as EBS volumes can only be attached to EC2 instances. Even if they were using EC2, video files are typically large in size, so you may have to use multiple EBS volumes to store that data, which might not be cost effective in the long run. So EBS is out. Instant storage is out for the same reason. We're not using EC2 here, but also because we want this data to persist for a year, and instant storage is considered ephemeral.
All right, S3 it is. Let's put some points on the board for those who got it right. Morgan, tell us the next question.
The next question is, you're an architect for an e-commerce company that wants to run their MySQL database on an EC2 instance. This database needs a storage layer to store their order and customer information. The database will frequently be accessed and updated, so the storage layer needs to respond quickly. It's important that the storage is fast and durable. Which AWS storage service should you use? You have 5 seconds.
EBS.
And the answer is Amazon EBS. Add 30 points to your score if you got it.
It seems like we're looking for storage attached to the compute, so why not EC2 Instant Store?
Right, that's also an option, but it's not ideal. Since it's an e-commerce company, their order and customer data is what drives the business, which means the persistence and durability of that data is really important. Using EC2 Instant Store would definitely give us the speed we're looking for, but it wouldn't give us the durability needed to store this data long term. So EBS is the right option.
That makes sense. All right, moving on. 2 more questions. The next one is, you have a web application that needs to write to disk in order to perform certain calculations. The application will store temporary data during the calculation. The most important aspects of this architecture are speed and cost. With 5 seconds on the clock, which storage solution would you choose? And the answer is EC2 Instant Store.
Seth, would you mind telling us how we chose Instant Store and not EBS?
Sure. Once again, we're looking for storage attached to compute in this case. The first thing I want to point out is that this is temporary data we're talking about. We're not looking at a huge amount of data, and we also don't necessarily care about the durability of that data. If the instance fails mid-calculation and you want to plan for failure, you can just restart the calculation from scratch. So durability doesn't matter, but cost does. By not using EBS and instead using Instant Store, you may save yourself some cost. That is because Instant Store is included in the overall EC2 instance price. So Instant Store is the best option for this use case.
Okay, 30 more points on the board for those of you who got it. Now, the final bonus question for an extra 10 points is next. This is a tricky one, and you might have to think outside of the storage options that we've talked about so far. The question is, let's say you're creating a WordPress site on multiple instances. By default, WordPress stores user uploads on the local file system. Since you want to use multiple instances, you'll need to move the WordPress installation and all of the user customizations into a shared storage platform. Which storage option would you use? 5 seconds to go. And the answer is Amazon Elastic File System, or Amazon EFS. This service was covered in an earlier reading, so if you got points for this, great job. For those of you who didn't, no worries, but I would recommend that you go back and review the reading related to file storage on AWS.
Let's go ahead and talk about the options. Typically, when we talk about shared storage systems that multiple instances can access, we think Amazon S3. Why wouldn't we use that in this case?
Well, S3 isn't a file system, it's actually a flat structure for storing objects instead of a hierarchy, and you can't mount it onto multiple instances. Because S3 has a different underlying type of storage, it's not right for this use case. So, by moving the entire WordPress installation directory onto an EFS file system and mounting it onto each of your EC2 instances when they boot, your WordPress site and all of its data is automatically stored on a distributed file system that isn't dependent on any one EC2 instance.
Nice. Well, you answered all 4 questions and you win the grand prize of the satisfaction of getting them all right. Congratulations, and that's it for today's show. Hey everyone, welcome to our exercise walkthrough on creating an S3 bucket and then modifying the EC2 instance holding the application to utilize this S3 bucket. As you can see, I'm already in the AWS Management Console and I'm logged in as the admin user that was created before. So the first thing that I need to do is to create the S3 bucket that will be utilized by the application. To do that, I'm going to go up to this search bar here and type in S3 and then click on the S3 service to be taken to the S3 console. Now that I'm in the S3 console, I'm going to go ahead and click Create Bucket. And for my bucket name, I am going to use employee photo bucket dash SR as my initials, and then dash and just 3 random digits. So I'm going to go with 963. I do want to make sure that my bucket is in the same region as the rest of my infrastructure. So I'm going to keep this as the Oregon region or US West 2. And then I'm going to keep all of the other defaults as they are. From there, I'll go ahead and click Create Bucket. And as you can see, my bucket has been successfully created. Now that the bucket has been successfully created, I want to test uploading an object just to make sure that it all works. So I'll click on the name of the bucket, which will take me to the bucket details page. And to upload a file, I can click this upload that's in the center of the page here, but more often I'm going to use the one in the upper right. So I'll click that upload button and then I'll click add files and I'll go ahead and upload this employee to photo. After I add that file, I can click upload. And as you can see, the upload of that file was successful. So I'll go ahead and click close there. And in a previous demo, you might have seen a way to make this object publicly accessible. But for this bucket and for the exercises moving on, we don't want this bucket to be just completely open to the world. We want this bucket and these objects to specifically be accessed by the application. And so in order to do that, we need to adjust the permissions for this bucket, specifically the bucket policy. So since I'm already in the bucket details page, I'm going to go ahead and click on this permissions tab. And I want to adjust the bucket policy for this bucket. So I'm going to scroll down to bucket policy and click the edit button, which will take me to a spot where I can create a bucket policy. So to create this bucket policy, I'm going to take the policy and paste it here. But before I move forward, before I save this policy, I need to edit a few things. The first thing that I need to edit is the account number so that I am utilizing the correct account. And that will be done here where it says insert account number. And I will paste my account number there. And then from there, I will also scroll down and change this area where it says insert bucket name and put my bucket name there. And I need to make sure to do that in both locations and make sure that I'm also removing the caret brackets when I do so. So now that I've done that, I can go ahead and save these changes and my bucket policy will be created. And now my account with this specific role will have access to this bucket and the objects within this bucket. So now that I have tested uploading an object and created the bucket as well as providing access to the bucket by that role,
I need to modify the application to utilize this bucket. So to do that, I'm going to go over to EC2 and click on instances. And as you can see, my stopped instance from previous exercise is there. And there's a cool little shortcut that can be used in order to clone this instance so that I'm launching basically the exact same thing and making sure that I maintain those settings. So to do that, what I'll do is I'll select this stopped instance, and then I'll go over to actions and down to image and templates. And then I can click launch more like this. What that's going to do is open up my instance launching page, but already have certain things filled out so that my instance is going to be a clone of the stopped instance that I've already launched. So what I want to do is make sure that I know that this is my updated application instance. So to do that, I'm going to append -S3 to the end of the instance name. So it'll be employee directory app S3. And my image and instance type are going to remain the same. So what I can do is just make sure that I'm using the same key pair that I'm using with my other instances. And then I want to scroll down and make sure that this is going to be accessible. So I want to change my auto assign public IP to enable. And that's just going to make sure that I have a public IP address to access for this instance. From there, I'm going to continue to scroll down as all of the other settings are still correct. And then I'm going to expand advanced details. With the expanded advanced details, I can see that the role is already associated to this instance. And I'm going to scroll all the way down to the user data. And what I need to do is put my bucket name in here so that now my application knows what bucket to utilize. And so with my bucket name there, I can now launch my instance. And that will just take a little bit of time. So I'll go over to my instances and I'll wait for that to be launched, just occasionally refreshing it to make sure that everything launches correctly. And I want to wait until the status check is showing 2 of 2 checks passed. So now that I've given it some time, I'm going to go ahead and click refresh again. And as we can see, there are 2 of 2 checks passed. So I just want to make sure that this application is up and running. I will select this instance and copy its public IP address. And then in a new tab, I will go ahead and paste that IP address. And as we can see the application is up and running. We still can't interact with this application yet because the database hasn't been associated. So that is just to make sure that the application is up and running, and we'll be able to interact with it in just a bit. So now that that's been done, just want to do a couple of the closeout tasks for this and stop this instance, as well as delete the object that was uploaded to the S3 bucket. All right, that's it for this one, and I will see you in the next exercise.
the employee directory application that we've been building out lets you keep track of employee data like their name, location, job title, and badges. The app supports adding new employees, viewing existing employees, as well as editing and deleting employees. All of this data will be stored in a database, which we haven't created yet. According to the architecture diagram, we have chosen Amazon Relational Database or Amazon RDS to store this data. So let's talk about databases for a moment. Relational databases are widely used across all industries, and it's likely your company has many databases supporting a variety of applications and solutions. Relational database management systems, or RDBMS, let you create, manage, and use a relational database. You can install and operate database applications on Amazon EC2 instances, and this is a good option for migrating existing databases to AWS. By running databases on EC2, you are already simplifying things from an operational perspective when it comes to on premises, and it's a common use case for EC2. When migrating a database from on premises to EC2, you are no longer responsible for the physical infrastructure or OS installation, but you are still responsible for the installation of the database engine, setting up across multiple AZs with data replication in place, as well as taking on any database server management tasks like installing security patches and updating database software when necessary. So EC2 makes it easier, but there is a way to lift even more of the operational burden of running relational databases on AWS. What if instead of managing a database on EC2, you could use one of the managed AWS database offerings like Amazon RDS? The big difference between these two options is instead of taking care of the instances, the patching, the upgrades, and the install of the database, AWS takes care of all of that undifferentiated heavy lifting for you. The task that you are then responsible for is the creation, maintenance, and optimization of the database itself. So you are still in charge of creating the right schema, indexing the data, creating stored procedures, enabling encryption, managing access control, and more. But all of the rest of the undifferentiated heavy lifting that goes into operating a relational database, AWS takes care of. To start off this section of lessons on databases, we will first cover RDS. The upcoming reading after the video will dive into the history of enterprise relational databases and explain what relational databases are and how they were used. If you aren't familiar with databases, the readings coming up will give you some useful background information.
You hear me?
Yes, I can hear you. How can I assist you?
Okay, could you clarify the difference between a database and storage in the context of AWS?
Sure. In the context of AWS, a database is a structured collection of data that allows for efficient querying, updating, and managing of information. AWS offers services like Amazon RDS, Amazon Aurora, and Amazon DynamoDB, which provide databases for different use cases, such as relational and NoSQL databases. Storage, on the other hand, refers to services that allow you to store and retrieve files, objects, and data. AWS storage services include Amazon S3 for object storage, Amazon EBS block storage for EC2 instances, and Amazon Glacier for long-term archival storage. In summary, databases are for managing and querying structured data, while storage is for saving and retrieving files and data.
Okay, what's the difference between MySQL and the NoSQL?
The main difference between MySQL and NoSQL databases lies in their structure and the type of data they handle. MySQL is a relational database management system, RDBMS, that uses structured query language, SQL, to manage and query data. It organizes data into tables with predefined schemas, which makes it suitable for handling structured data with relationships. Examples include financial data and user records. NoSQL databases, on the other hand, are designed to handle unstructured or semi-structured data. They don't use a fixed schema, allowing for more flexibility in data storage. NoSQL databases come in various types, such as document stores like MongoDB, key value stores like Redis, column stores like Cassandra, and graph databases like Neo4j. In summary, MySQL is great for structured data with defined relationships, while NoSQL is better for flexible, unstructured data and scalable performance.
So the difference is MySQL is for structured data, and the NoSQL is flexible data.
Yes, that's a good way to summarize it. MySQL is for structured data with predefined schemas and relationships, while NoSQL is for flexible, unstructured, or semi-structured data without fixed schemas. This makes NoSQL more adaptable to varying data types and scalable needs.
Amazon RDS is a service that makes it easier for you to set up, operate, and scale a relational database. Instead of telling you about RDS, I am going to show you. As you can see, I'm already in the Amazon RDS dashboard. We are going to create the relational database our employee directory application can use to store employee data. First, we will click Create Database, and then we are going to select the Easy Create option, which gives us the ability to accept the standard best practices for backups and high availability. You could select Standard Create if you wanted more granular control to pick and choose the different features of your database setup. Next, you choose the database engine. You can see what is currently supported at the time of this filming for database engines on RDS. And the common engines out there are MySQL, PostgreSQL, MariaDB, Microsoft SQL Server, and then there's this one, Amazon Aurora. Amazon Aurora is an AWS-specific database that was built to take advantage of the scalability and durability of the AWS cloud. Aurora is designed to be drop-in compatible with MySQL or PostgreSQL. It can be up to 5 times faster than the standard MySQL databases and 3 times faster than standard PostgreSQL databases. So if you have some use cases that require large amounts of data to be stored with high availability, durability, and low latency for data retrieval time, consider using Amazon Aurora over a standard MySQL or PostgreSQL RDS instance. In our case, we really only need a simple database without any high performance or large storage requirements. So I'm going to select a standard MySQL instance. Next up, we will choose the database instance size and type. This database instance is similar to how we choose an EC2 instance size and type. Since this is just a demo, I'm going to select a free tier eligible instance. Now we'll give this database a name and assign the database an admin user and password that would be used to connect to the database. Then we will accept the rest of the Easy Create defaults, and we are done with this instance creation. You can see that the instance is in the process of booting up, and that will take a few minutes to complete. So in the meantime, let's talk about high availability and RDS. When you create an RDS DB instance, it gets placed inside of a subnet inside of a VPC, very similar to an EC2 instance. As you learned already in a previous lesson, subnets are bound to one AZ. And as a best practice for production workloads, we recommend that you always replicate your solutions across at least 2 AZs for high availability. With RDS, one DB instance belongs to one subnet inside of one AZ. So that isn't meeting the criteria for best practices. Now, before you get worried about managing this all on your own, just know that you can easily configure RDS to launch a secondary DB instance in another subnet and another AZ using RDS multi-AZ deployment. And RDS will manage all of the data replication between the 2 instances so that they stay in sync. The other cool thing about RDS multi-AZ deployments is that RDS also manages the failover for the instances. One instance is the primary, and the other is the secondary database. Your app connects to one endpoint. If the primary instance goes down, the secondary instance gets promoted. The endpoint doesn't change, so no code change is needed. All of the failover happens behind the scenes and is handled by RDS. All you do need to do is to make sure that your app can reconnect to the database if it experiences a momentary outage by updating any cache DNS lookups and reconnecting to the endpoint, which now connects to the secondary instance. Pretty cool if you ask me. All right, and we're back in the console and we can see that our instance is up and running. At this point, you can connect to the database instance and load your database schema onto it, ready to go, and much, much simpler than trying to install and manage this all on your own. Using services like RDS make operating databases significantly more accessible and lowers the operational overhead that comes along with relational database management.
With Amazon RDS, you can offload some of the unrelated work of creating and managing a database. You can focus on the tasks that differentiate your application instead of focusing on infrastructure related tasks like provisioning patching, scaling, and restoring. Amazon RDS supports most of the popular RDBMS, ranging from commercial options to open source options, and even a specific AWS option. Supported Amazon RDS engines include the following: commercial, Oracle, SQL Server, open source, MySQL, PostgreSQL, MariaDB, Cloud Native, Aurora. So these are databases management tools. Microsoft SQL Server, Oracle, PostgreSQL, Aurora, right? MySQL, database instances. You have control over managing access to your Amazon RDS resources, such as your databases and a DB instance. How you manage access will depend on the tasks you and other users need to perform in Amazon RDS. Network ACLs and the security groups help users dictate the flow of traffic. If you want to restrict the actions and the resources others can access, you can use AWS Identity and Access Management IAM policy. IAM and IAM policies and permissions. Or transport layer security. Secure sockets layer SSL. Or transport layer security. Connection with DBSs.